our the third equation of uniform motion that we can get. Now, the first one we had was v, that's final velocity, equals to initial u plus acceleration times time. And please don't forget about the units at which you will use to calculate each of these parameters. For velocity here, the unit for the velocity is meter per second. So if the unit of velocity was given in kilometer per hour or megameter or something of such, you have to convert it to meter per second before you now substitute. You also, the unit for it is meter per second. A, which is acceleration, the unit for it is meter per second square. So if you are given acceleration in any other higher unit or with prefix like kilometer per second or kilometer per hour square, there's something, so you have to convert it to meter per second square. And then t, the unit for time is seconds. So if you are given time in any other unit other than seconds, you have to convert it to seconds. If you are given it in hour, you convert from hour to seconds. If you are given in minutes, you convert it. If you are given in days, you convert it to seconds. So we proceed. And then the second equation we developed was average velocity, v bar, to be equals to what? Final velocity plus initial velocity over 2. And then in which the unit for this is still the same. So, and then average velocity, can also be written as what? Displacement over time. Velocity, definition of velocity is what? The rate of change of displacement. While speed is defined as what? The rate of change of distance. The rate of change of distance. The reason we use displacement for velocity is because velocity takes in consideration direction of motion and is a vector quantity. So vector quantities are quantities that have direction, magnitude, and direction. Scalar has magnitude, no direction. Example, speed, but velocity is a vector. So average velocity is what? Final velocity plus initial velocity over 2, everything over 2, which is the same thing as what? Displacement over time. So we proceed. So how do we now get our next equation of motion? Now, since we have seen what our average velocity is, we are going to consider this other part of this equation that says displacement over time equals to what? V plus u divided by 2. So when you do this and then you recall our first equation here, that velocity, final velocity equals what? U plus at, and you substitute it where you have v here. When you say v equals to this, that means wherever you see v, you can also put what that represents v there. So that you now have that displacement over time equals to, when you put this in place of v here, that will now be u plus at, that represents the v, then plus what? U here. So everything divided by 2. So we proceed. and we remove the bracket there, s over t, and the s over t. Now, since this is not a multiplication, you can just remove the bracket. It will have no effect. This is addition. What you have here is addition. So if you remove the bracket, it won't affect anything here. So that you have u plus at plus u divided by 2. So you operate the like terms. You have a u term here, you have a u term here. So u plus u will give you 2u. So we have s over t equals to 2u plus at over 2 plus at over 2. Now this over 2 here means that 2 on this denominator is the LCM of the denominators of each of these. It means that these two divide each of these term here. It divides 2u and also divide at. So if you have s over t will now be equals to what? 2u over 2 plus at over 2. So, and you find that that's to show you that this denominator was their LCM, the individual fractions that you can get from here. So 2 here will cancel 2 here. So we have that s over t will be equals to u plus what? I have what? 80. U plus I have 80. So when you do cross multiplication, or you say make s the subject of the formula, what you now have is s will be equals to t times everything on the right hand. T times this is t times u plus I have 80. So when you do that, so you have that s will now be equals to t times u, that will be ut. T times I have 80, that will be plus I have at squared. So that's how you derive the next, or you can say the third equation of uniform motion. So here what it means is displacement equals to what? Ut, which is initial velocity. Ut, which is initial velocity times time, plus a half of what? Acceleration times time squared. So where your displacement is, the unit for your displacement will be in meters. So if you are given in kilometers or any other unit or centimeters, you convert it to meters. And then your velocity, initial velocity, will be what? In meter per seconds. Your acceleration A will be in what? Meter per second square. And your time T will be in seconds. So you plug it there to look for whatever you are looking for. Either you are looking for time or looking for acceleration, depending. But make sure that all the units are in their standard form or in their SI unit. Okay, so this is our third equation of motion.